Hello everyone from Math 2000. It's linear algebra. It's Professor Wenson here again with a video on section 1.5 from your ZyBooks titled Solution Set of a System of Linear Equations. Alright, so I'm just going to be going over the ZyBooks section. Here it is. So you have 1.5 Solution Set of a System of Linear Equations. Now you've seen earlier in the chapter what a system of linear equations is and what are solutions of a system of linear equations. The solution set of a system is the set of all the solutions, right? We're going to describe in some way all the solutions, if any, to a system. Now there's some more definitions here. It starts off with every system of linear equations, without exception, has either no solution, one solution, or infinitely many solutions. Right? So we have to decide which of these three scenarios we're in based on an augmented matrix for the system. And in the sections after this, we're going to take the augmented matrix for a system and use elementary row operations to put that matrix into either echelon form or reduced echelon form. Right. So we got the objectives of the section here. You'll be able to identify basic and free variables. So we'll see some definitions of what does it mean for variables in a system to be basic and variables to be free. Then we're going to go into that part where I said, we're going to determine the number of solutions to a system. Does it have no solution, one solution, or infinitely many? And if it has infinitely many, can we describe them all? Right? And that's what the parametric form of the solutions to a system means. When they say find the parametric form for the solutions to a system that has infinitely many solutions, this parametric form is a description of all the infinitely many solutions, a way to find them all. All right. So here are some very important definitions. Things that are these words will come back over and over again throughout the rest of the semester and be used many times. So basic and free variables. If a system has an infinite number of solutions, the solutions can be expressed using two types of variables that correspond to the pivot and non-pivot columns in the coefficient matrix. Remember, for an augmented matrix, you had a coefficient matrix and then the matrix of constants after the bar. So we're going to be focusing on the pivot and non-pivot columns of the coefficient matrix when you talk about what variables are basic and what variables are free. A basic variable, sometimes basic variables in other books, if you're reading some other stuff out there, sometimes basic variables are referred to as leading variables. Right, just keep that in mind if you ever see that. A basic variable corresponds to a pivot column in the coefficient matrix. Now remember, pivot columns, pivots only happen, you only have pivots when your matrix is in echelon form or reduced echelon form. Right? So once you get your matrix into echelon form or reduced echelon form, a pivot column will correspond to a basic variable, what's called a basic variable. A free variable corresponds to a non-pivot column in the coefficient matrix. The reason it's called free is because a free variable can take on any arbitrary value. Right? You can you're free to choose whatever values you wish for that variable. When free variable or free variables, some systems of equations will have more than one free variable. When free variables exist, each basic variable, which corresponded to the pivot columns, can be represented in terms of one or more of these free variables. All right, so here's an example. All right, and let me show you what I mean. We'll get the solutions in a little bit, but I'm going to write this system out. I can play the animation for you, but I'm going to write it out as well, show you on paper. And we'll identify, you have a system here with three variables, x1, x2, x3, and you can identify which variables are basic, which variables are free. All right, so here is that same system. And remember, every system of linear equations, which this is a system with two linear equations, three variables, and every system of linear equations can be represented by an augmented matrix. Now you have to get it in this specific form where all the variables are on one side and constants on the other side of the equal signs. But once they are, right, then we can go and write the augmented matrix, or the matrix representation for this system. Right, where down the first column go the coefficients of the first variable, x1. So there's 1x1 and then 0x1. And then down the second column go the coefficients of x2, right, 2x2 and then 1x2, so 2 then 1. Then down the third column of the matrix go the coefficients of the third variable, negative 1x3 and negative 2. And then there was a bar, usually a bar written to represent where the equal signs go. And then your constants down the last column, 4, then 8. And if you recall again, this matrix to the left of the bar, this 2 by 3 matrix with the 6 entries, this is called the coefficient matrix. And then this this matrix here, this 2 by 1, 2 row 1 column, this was just the matrix of constants, or the constant matrix of constants on the other side of the equal signs. Right? All right. Now if you look at this, when I write this as an augmented matrix, now as a whole, when you look at the whole thing, it's a 2 by 4, right? 2 rows, 4 columns. This is remember, this is in echelon form, right? This is in echelon form, or row echelon form, that you might see it called in other texts. Remember, like, there's no rows of zeros, but all the leading entries that come are to the right of the leading entries above it. Right? The leading entry of the first row is a 1. Leading entry of the second row is also a 1, and it's to the right of that 1 above it in the first row. And every leading entry has zeros below it, right? The leading entry 1 has zeros below it. This leading entry of 1, there's nothing below it, so you can just say, there's zeros below it, fine. Nothing below it's fine. Now, it's in echelon form, but it's not in reduced echelon form, right? Because you have those two other conditions. The lead entries are 1, fine. But the column, the leading ones need to have zeros below and above them, and this one has a 2 above it, right? So this is an echelon form, but not reduced echelon form. But it doesn't matter, right? When you're in one of the echelon forms, you have what are called pivots, right? And pivots are leading entries. So this leading 1 is a pivot, and then this leading entry 1 is another pivot, right? So each of these columns, and again, this is only in the coefficient matrix. When you talk about where the base, what correspond to basic and free variables, you look at the coefficient matrix. What columns are pivot columns, right? And you did this in the last section. So these, I'm going to draw over that. These are pivot columns. Column 1 and column 2. And then column 3 does not have one of these leading entries, right? So column 3 in the coefficient matrix here, grab a better marker. All right, so column 3 in this coefficient matrix is a non-pivot column. Right, and don't worry about, right now we're focusing on the coefficient matrix, right, to the left of the bar, because all these, we're going to decide which variables of the system are basic, which ones are free. And the columns that only correspond to variables are the ones in the coefficient matrix, right? The 4 and the 8 don't correspond to terms with variables, right? But all these numbers do. Right? All right, so since these are pivot columns, right? Column 1, column 2, we would say that the variable x1, right? Because the first column corresponds to the coefficients of x1. We would say that x1 is a basic variable. All right. And the same thing would go for x2 and x2. All right. The second column was a pivot column. That corresponds to variable coefficients of x2. So x2 is also considered then a basic variable. All right. And then it's any columns in the coefficient matrix that are not a pivot column. Right? Column 3 was a non-pivot column. So, and these numbers were coefficients of x3. So x3, the variable x3, is considered a free variable. Okay. So you have basic variables and free variables. All right. Now, what they were saying a minute ago, earlier in my reading, is that once you've identified your basic variables and free variables, you should be able to now express the basic variables in terms of the free variables. All right, so this is actually something that's going to come up a lot later, but I'm going to do that right now. So you should be able to express every variable in the system, the basics especially. We should be able to express each variable of the system in terms of the free variable, or free variables, but this one only has a free variable. All right. So, you go through, once the system's in echelon form here. What I do is I take the bottom equation, x2 minus 2x3, equals 8. This is a basic variable, right? This is the free variable, x3. So I'm going to solve for the basic variables. All right? So basically to solve for the basic variables. So you see that x2 would be 8 plus 2x3. And then noting this, and looking at the first equation, all right, I'm going to replace x2 with this 8 plus 2x3, and we have x1 plus 2 times x2, right, 2 times x2, but x2 in terms of the free variable is 8 plus 2x3. Right, and then we have minus x3 equals 4. And then I can, now you see I can express the other basic variable. I can express x1 in terms of x3. Right? I can express the basic variables in terms of the free variables. Right? So if you were to solve this for x1, all right, you would have 2 times 8, 16. I would subtract 16 and get a negative 12 over on the right side. Then you have plus 4x3, which minus x3 would be plus 3x3, and then I subtract that minus 3x3. And then of course the free variables are equal to themselves, right? So x1 is negative 12 minus 3 times x3. x2 is 8 plus 2x3 in this system. And like I said, the free variables are equal to themselves. x3 equals just x3, clearly. Right. And what we have here, and we'll get to this later, this is a description of all the solutions, how to find all the solutions to this system by just replacing the free variable with any number you want. I can replace x3 is the free variable. I can replace x3 with any number I wish and get a solution to this system, right? Like if x3 were 0, right? If x3 were equal to 0, then we get a solution to the system. X1 is negative 12 minus 3x3, so negative 12 minus 0, x1 equals negative 12. x2 is 8 plus 2 times the free variable, right? So 8 plus 2 times 0 is 8. And of course, again, x3 is 0. Right? x3 is x3. And there's a solution to the system, and you can check it. Negative 12 plus 16 is 4. And then 8 equals 8. I mean, this works out. And you could replace x3 with anything you want, right? It's free. All the free variables can be replaced by any numbers you wish. And then you solve for the basic variables. All right, so I'm getting ahead of myself here. This will actually come up later in the reading. All right. But once your augmented matrix is in echelon form or reduced echelon form, you should be able to identify the basic variables and the free variables. And again, here's the animation for the. This is exactly what I went over. All right, I read it as an augmented matrix. It's in echelon form. The variables that correspond to pivot columns are basic, x1 and x2, and then all the other ones, that are for not all the other ones in the coefficient matrix. Notice they didn't highlight to the right of the bar. They didn't highlight the matrix of constants. Just in the coefficient matrix you're going to use to identify the free variables and basic variables. All right, so here's a system in 5 variables, x1, 2, 3, 4, and 5, has the reduced echelon form below, right? So again, you see this first column corresponds to coefficients of x1, then x2, x3, x4, x5, and then you have equals 4, 2, and negative 3, the constants on the other side. Determine whether each variable is a basic variable or a free variable. So looking at this system, look at the coefficient matrix right to the left of the bar. It's in reduced echelon form, right? So it's in echelon form. Where are the pivots? The pivots are those leading terms, 1, 1, and this one here. What columns do they show up in? That this leading term is in the first column. This leading term is in the third column. And this leading term is in the fifth. So x1, x3, and x5 would be the basic variables. And then the two other columns, the second column and the fourth column that don't have a pivot, correspond to the free variables, x2 and x4. So x1 is basic. I've already explained it all. x2 is free. x3 is basic, right? There's a pivot there. That's a pivot. That third column was a pivot column. x4, the fourth column was not a pivot column, so x4 is a free variable, and x5 was a pivot column, right? So a basic variable. So hopefully it's easy. Again, the matrix has to be in either one of the echelon forms, right? All right. Now what I was doing a minute ago, where I was expressing every variable in terms of the free variables, right? Getting x1 equals whatever I had, negative 12 minus 3x3 or something like that, and x2 equals 8 minus 2x3 or whatever I had on the earlier paper. When you express all the variables in terms of the free variables, you're describing the general solution to the system, how to get all the solutions, the solution set. So I'll read this out. Right? Any system of linear equations that has infinite solutions will always contain at least one free variable. When free variables exist, the value of each basic variable depends on the value of one or more free variables, right? That means you can solve for the basic variables, and then on the other side you have an expression depending on the free variables. Expressing a solution to a system of linear equations in parametric form involves writing basic variables in terms of free variables, while free variables are left as arbitrary, right? As I mentioned earlier, the free variables are equal to themselves. Right? x3 was equal to x3 earlier. Like unique solutions, solutions in parametric form can be expressed as an n-tuple, right? An ordered tuple. However, parametric form is normally expressed as a column matrix. A solution expressed in parametric form is called the general solution to a system. Right? You're describing all the solutions. Right? And this is, again, for systems that have infinitely many solutions. All right, so here's an example here. Now, again, you can read through this. I'm just going to pull this up on a paper. Again, I'll write this out. Okay, so I've written out the system they had there with the variables. x1 plus 5x3 equals 6. Second equation in the system had x2 minus 3x3 equals 4. I can express the system, I can represent it with an augmented matrix. Right, or again, a little matrix notation here. Down the first column, the coefficients of x1, which in these equations are 1 and 0. Down the second column, the coefficients of x2, which are 0 and 1. Third column, the coefficients of the x3 variables, positive 5, negative 3. And a bar representing where the equal signs are, and then the constants on the other side, 6 and 4. All right, so this matrix represents that system. Now, if you look at this and go through the criteria, this particular matrix is in actually, not just echelon form, but it's also in reduced echelon form, meaning it has pivots, right? The only types of matrices that have pivots are echelon form matrices. I can't spell form, okay. So it's in reduced echelon form. And where are the pivots, right? That's what those are, just those leading terms. Here's a pivot, and here's a pivot. Right? So again, columns 1 and 2 are pivot columns. So that means that x1, right? The first column corresponds to has coefficients of x1. So x1, and the second column corresponds to coefficients of x2. So x1 and x2 are going to be, again, what they call basic variables or leading variables. But just to stick with this text, it's basic variables. The third column in the coefficient matrix. Don't worry about the fourth column. Don't worry about the column after the bar. All right, we're talking about the columns that, we're just talking about the numbers that have variables attached. The third column does not have one of these pivots. It's a non-pivot column. So the third variable, x3, is again a free variable. Right, is a free variable. Meaning, I can replace x3 with any number I wish and get a solution to this system. Right? This system will have infinitely many solutions. All right, so now, when I try to write the general solution of the system, I'm going to write it in terms of the free variable. That means so solve for the basic variables. Solve for the basic variables. All right, get them in terms of the free variables, and the free variables only. All right. Get them in terms of just the free variables. So that's where I go back to the system, right, and we go from, I'll work from the bottom up. Right, work from the bottom up. So you see that bottom equation. We have x2 minus 3x3 equals 4. Right, this was basic. This is free. Solve for the basic. So I would add 3x3. So we have 4 plus 3x3. There's x2, and there's a basic variable in terms of the free variable x3. All right, and then I go up and work with the other equation was this: x1 plus 5x3 equals 6. And this was basic, x1. This is free. x3 was a free variable. If there were any other basic variables, I would replace it with, like I did earlier, I'd replace any basic variable with an expression depending on a free variable. All right, then I solve for the basic variable. So x1 here would be 6 minus 5x3. Right. And then x3 is itself. Right? So we've accounted for every variable. So the general solution to this system, right, the system I started with way up here, those two equations, is the following. I can replace x1 with 6 minus 5x3. I replace x2 with 4 plus 3x3. And I replace x3 with whatever our x3 is, right? Every free variable, right? Or you could just write x3 is a free variable. You can let it be whatever you want. Right, that's an R, sorry. Okay. Now this could also be written in what's called parametric form as a column matrix. In parametric form, this same, just put 6 minus 5x3 in the first spot, telling me that that's what the value of the first variable is going to be, x1. 4 plus 3x3 in the second spot, telling me what the value of x2 is going to be, and then just x3 in the third spot, what the value of x3 is. It's called a parametric form. You could also write this, as they mentioned, as now this would be a 3-tuple, right? Because there are 3 values. Just like an ordered triple, the first value is 6 minus 5x3. This is the value of x1. The second value, x2, is 4 plus 3x3. And the third value is just x3, right? But again, every single spot, every single place is dependent upon the free variable. Everything depends on the value you choose for the free variables. All right, so keeping this in mind, we can bring up some examples of solutions to this system. Just replace x3 with whatever you want. So how about if x3 were equal to 1? Then a solution to this system is the following. I'll just do an ordered triple. If x3 were 1, you'd have 6 minus 5 for x1, 4 plus 3 for x2, so 7, and then just 1 for x3. So 1, 7, 1 would be a solution to this system. Let's see. Let's go back to the system here. All right, here was the system. Replace x1 with 1, x2 with 7, x3 with 1. If I do that, you'll have 1 plus 5 equals 6. That's true. And you'll have 7 minus 3 equals 4. That's also true. And that's just when x3 was 1. Right, I can replace x3 with anything I want. It's a free variable. How about if x3 were 10? Then a solution to this system would be the following. 6 minus 50 would be negative 44 for x1. Then 4 plus 30 would be 34 for x2. and then just 10 for x3. And there's another solution, another ordered triple that makes the system a true statement. And you could do this forever, right? There's infinitely many solutions, and this is a description of all of them, right? This parametric form, or this tuple here, or this here. It's just a description of how do you find any of the solutions to this system. And let's test this last one. All right, so here's the system again. Negative 44 plus 50 is 6. Yes. 34 minus 30 is 4. Yes, this is a good solution. And again, you could do that all day long. Replace the free variable with any value you choose, and you'll get a solution, as long as you've expressed the basic variables, right, in terms of that free variable. All right, so again, you can play through the animation here. I'm not going to do that this time. And they picked some different values. Replace x3 with 0, and you get 6, 4, 0 as a solution. Replace x3 with negative 2, and you get 16, negative 2, negative 2 as a solution. All right, one thing I do want to point out. Sorry, back on the paper. Sometimes these free variables are replaced with other letters or other expressions called parameters. Right? Thus the name parametric form, parameter. So I'll mention this note here. Right? Sometimes, and I am going to do this quite often later in the course, right? In later sections. Sometimes free variables are replaced with another expression that could represent any real number. Again, only the free variables. So sometimes the free variables are replaced with another expression that could represent any real number. So for example here, see how x3 was a free variable? In the previous example, suppose I let x3 be replaced by the letter t, the expression t, where t is any real number. It belongs to the real numbers. You've probably seen this means belongs to the real numbers. So that way I don't have to keep writing x3. I can just write the letter t, something simpler. Very often I'll do this in future problems. So then the general solution to that system looks like the following, where x1 is 6 minus 5x3, but instead of x3, I'm going to say t. 6 minus 5t. And x2 is 4 plus 3x3, but again, I'm replacing x3 with t. 4 plus 3t. And x3 is x3. x3 is just t. All right, so you could do this as well, and then just replace just replace t with any real number. All right, so if I replaced, if I went through here and replaced t with 1, I get the solution 171. If I replace t with 10 here, I get the solution negative 44, 34, 10. All right. Yeah, so I mean, it might not seem, you might not understand why this is done now, but there is a reason that will be made clear later in a later section. Why do we replace, or why is it often the case that free variables are replaced by some other expression that represents a real number? All right, so just know that's out there. All right, that you can do that. All right, so back to the page. All right. So here's a participation activity. So here's the augmented matrix of some system in reduced echelon form below. Right? So true or false, x1, x2, and x4 are the basic variables. Right? well, where are the pivots, right? They're already telling me that this is in reduced echelon form. So the pivots are just the leading entries, 1, 1, and 1. All right, and the last two rows don't have any leading entries. So 1, 1, and 1, those are the pivots. They're in column 1, column 3, and column 4. Right? So x1, x3, and x4 would be the basic variables, not x2. So this is false. All right, see, x2, the second column, does not have a pivot. Are x2 and x5 free variables? Yes, the second column doesn't have a pivot, doesn't have one of these ones, these leading ones, and the fifth column doesn't have a pivot. So x2 and x5 would correspond to the free variables. And then what's the general solution? All right. So, I'll pull this up on paper. Actually, let me bring this down, and hopefully you can see my paper on screen here. All right. Okay, so that first row, the 150039, that corresponds to this equation. That's x1 plus 5 times x2, plus 3 times x5, right, equals 9. That's what that first row corresponds to. The second row corresponds to 1x3, and that's in the third column there, minus 2x5 equals -7. The third row of the matrix corresponds to x4, 1x4, plus 8x5, then equals 6. All right, and then you have 0 equals 0. All right, these last two rows correspond to 0 equals 0. 0 equals 0, but 0 equals 0 these are true statements, so you can ignore them. They're always true. All right, for those last two rows. So you can ignore entirely 0 rows, all right, when you're going about solving systems. Now, I'm just going to solve each of these. Now again, x2 and x5 are the free variables, right? x2 and x5 are the free variables. All right, I'm going to go to make this a little bigger so you can see more of what I'm writing. So I'm going to solve for the I'm going to get the basic variables in terms of these two. All right, I want the basic variables x1, x3, and x4 in terms of these. Well, if you solve this last equation, it's x4 would be equal to 6 minus 8x5. There's a basic variable in terms of the free variables. This equation here, solve for x3. x3 would be equal to -7 plus 2x5. x2 is just x2. Right, x2 is just x2, that's free. x5 is just x5. And x1, and just solving the top one, would be 9 minus 5x2 minus 3x5, right, solving for x1. And there's a description right here of the general solution to this system. All right, because you can replace x2 and x5 with anything you want. Right? So for example, if I let x2 be 1 and x5 be 3, all right, you can let x2 and x5 be any value you wish. Then a solution to this system would be x1 equals, let's say that's 9 minus 5, right? 5 times 1 is 4. And then minus 9, that's -5. All right, so if I replace x2 with 1, x3 with 5, x1 is -5. x2 is just 1, right? The value of the x2 there. x3 would be -7 plus 6, right? 2 times 3. -7 plus 6 is -1. x4 would be 6 minus 24, all right? 6 minus 8 times 3. It's negative 18. And then x5 would be x5. x5 would be equal to 3. This is a solution, right? Now we can check. You know, negative 5 plus 5 is 0, plus 9 is 9. That's true. Negative 1, then minus 6 would be negative 7. That's true. Negative 18 plus 24 would be 6. That's true as well. This is a good solution to that system. And you could replace x2 with any number you wish, and x5 with any number you wish, right? You can replace the free variables with any numbers you want. And you could also replace them with other letters. Remember how I replaced x3 with t earlier? You could replace x2 with s. You know, everywhere I see x2, I replace it with s, and replace x5 with t or whatever. You know, you can replace these free variables with other expressions that represent a real number. Okay. Now looking back at the activity, right? It says, you know, no, this is not. Now remember, we had 9 minus 5x2, right? And negative 7 plus 2x5. Right? This is not the general solution here. The signs are all wrong, as you can see on my paper on the lower right portion of the screen there. All right. So now the challenge activity. I'm sure some of them are going to have you write the general solution. Some of them are going to have you just identify variables. So here, a system in 4 variables has the reduced echelon form below. Where are the pivots? They're in the first column and the second column. And that's it. There's no other pivots. So the first column and second column, the first variable, x1, and the second variable are basic. And then the last 2 columns in the coefficient matrix, again, just the coefficient matrix, are not pivot columns. So they represent x3 and x4 would be the free variables. You could let those be whatever numbers you wanted. And I'll just do 2 of these. All right. This one, and they're telling you, see, the enter a variable as the letter underscore that number. So find the general solution to the given system. Now, if you were to put this into a matrix form, you would see it's in echelon form. In fact, let me pull that up. All right, let's pull up a piece of paper. No, let's stick to that and just bring it up in the lower right-hand corner of your screen there. See that system, if I write a matrix for it, the coefficients of x1 are 5 and 0. The coefficients of x2 are 0 and negative 2. And the coefficients of x3 are 20 and 0. And you have equals, and then negative 25 and negative 6. This is in echelon form. Right? This is in echelon form. x1 and x2 are basic. Right? Again, the first 2 columns have pivots. And x3 is free. All right, so I want to get everything in terms of x3 if I can. Now x2, I know the number, right? If negative 2 times x2 is negative 6, then x2 is simply 3. So x2 equals just 3 in the general solution. It's always 3. x3, right? x3 is free, so x3 is just x3. So x underscore 3, like that, like they asked me to enter. And then if we solve x1, solve for x1, I'd subtract 20x3 and then divide everything by 5. So x1 would be negative 5, then minus 4 x3. All right, again, where x3 is the free variable. All right, and there's the general solution. Check. And fantastic, move on. They go through the explanation down here. All right. So again, you finish that off. All right, so now into the part where it's titled Existence and Uniqueness of a Solution. All right, so the first question will be, does a system have a solution, right? Does a solution exist? Is the system consistent or inconsistent? And then if it's consistent, if it has a solution, the second question will be about uniqueness. If it has a solution, how many? Does it have just one solution or infinitely many? Well, you saw already that if it has a solution, then, if the system has free variables, or if the system has any free variables whatsoever, it's going to have infinitely many solutions. If it has no free variables, right, all the variables are basic, then it's going to have one solution. And of course, like I said, there are going to be scenarios where there are no solutions. And here's one right here. Look at this. Look at this matrix. This matrix here, you see the last row in this augmented matrix with my cursors flowing back and forth on? See, it's 0x1 plus 0x2 plus 0x3 equals 1. You see, that corresponds to the equation 0 equals 1. 0 equals 1 is a false statement, no matter what you put in for the variables, right? Something that's always false. That tells me that the system that this matrix represents has no solution. All right, so that's going to be key. All right, when you have your matrix in echelon form or reduced echelon form, if you have any rows that look like this, where it's all 0 to the left of the bar, and then some non-zero number to the right of the bar, that indicates there's no solution. That can't happen. All right, so they state that stuff here. So a system of linear equations is consistent, right? Has solutions if and only if the last column of the augmented matrix in echelon or reduced echelon form is not a pivot column. If it is, the system is inconsistent, right? You see again back up here. See, if you look at the whole augmented matrix, it's an echelon form, and the last column is a pivot column. It has a pivot, has one of these leading ones. Or you just see the equation 0 equals 1, hopefully, and say, hey, that can't happen, no solution, inconsistent. Now, if the last column is not a pivot column, or if you're not having that happen, if a system has solutions, if a system is consistent, right, it has solutions, then either the system has one solution, right, a unique solution, or infinitely many. The solution to a consistent system is unique if and only if the system does not contain a free variable. So if you have a system that has solutions and there are all basic variables, if every variable is a basic variable, there's only going to be one solution to that system. And as you've been seeing, if there are any free variables, there will be infinitely many. All right, so they go over some examples here. So like all these matrices are in echelon form. All right, all these matrices are in echelon form. And if you look at the first one, see there's a pivot 1, pivot 9, pivot -7, and then you see how the last column has a pivot. Look at this last row. It's basically telling you that 0 equals 1. So yeah, if you have 0 equals 1, 0 equals 2, 0 equals 10, that's not good. That means the system has no solution, right? So if the augmented matrix is in echelon form and the last column is a pivot column, the column after the bar, there's not going to be a solution. This second one, this middle matrix, is in echelon form. And notice how the x1 would be a free variable, x2 would be a free variable, it's a pivot column, a basic. x1 would be a basic variable, x2 would be a basic variable, x3 would be a basic variable. But then the fourth column does not have a pivot. So x4 is a fourth column, is representing a free variable. Right? x4 would be free, and the last column is not a pivot column. Notice, 0 equals 0 is fine. I mentioned that earlier. See, the last row is all zeros. 0 equals 0 is okay. That's true. The last column is not a pivot column, which is great. So I have a free variable. This would have solutions. Since the last column is not a pivot column, it has solutions. And since there's a free variable, there are free variables, it's going to have infinitely many. And then here, last column is not a pivot column. All the pivots are in the coefficient matrix here. And every single column in the coefficient matrix to the left of the bar has a pivot. So every variable, x1, 2, 3, and 4, is basic. There are no free variables. So there would only be one solution to a system like that. All right, so there's some quick things to look out for. All right, so this is what I'll finish off with here. I'll just do this first one, maybe the first two here. All right. First one. Now it says here all these matrices are in echelon form. Right? Every single one of these matrices is in echelon form already. We'll get into a section after this where we have to put things in echelon form ourselves. Right? It's not going to be given to us that way, but for right now they are. So look, it's in echelon form. What are the pivots? 1, 5, and 1. First column, second column, third column. x1, x2, and x3 are all basic variables. There are no free variables. And the last column doesn't have a pivot. So this is that last scenario where there's just one solution, right? No free variables, but there's still a solution. Here, this is in echelon form. The pivots are 2, right? The leading terms 2 and -7. But you see this pivot of -7 is in the column after the bar. It's in the last column. The last column is a pivot. And look at this second row. It says basically 0 equals -7. That's not true. So the last column's a pivot. 0 equals -7. That system would have no solution. Right. And then of course this would have infinitely many. It would have one. It has one free variable, right? Pivot. There's a free variable. 0 equals 0 is fine. I keep saying that, right? 0 equals 0 is okay. A whole row of zeros, you can just ignore that. Alright, so hopefully this was informative, right? Hopefully you saw how to look at a system of equations that's in echelon form or reduced echelon form already. Alright, if you look at a system of equations that's already in an echelon form, can you identify basic variables, right? Where are the pivot columns? Free variables, right? The variables you can let be anything, corresponding to the non-pivot columns. And then can you describe the general solution, right? And that's where you just express every variable in terms of the free variables. And also, could you look at a system in echelon form or a reduced echelon form? Could you look at a system like that and just tell me if it has no solution, one solution, or infinitely many solutions? You should be able to eventually do that pretty quickly. All right. So let me know if you have any questions, of course. And then you have the additional exercises, which are part of week 2's assignment. I didn't assign all of these. I would recommend you do them all though, just for extra practice. But there's only certain ones that I'm going to have you submit via write on paper and actually submit to me. You'll see those problems in assignment 2, and everyone has a solution available. You can see the solutions if you wish, but please try to do the problems before you look at the solutions. Actually try to learn something, because if you just look at the solutions, copy the solutions, you're not going to learn anything, and it's going to be really bad on exams for you. All right, so that's it for 1.5. Section 1.5 on solution sets of systems of linear equations, and thanks for watching.